Hi there boys and girls, and I just want to welcome to your new journey in Form 4. Alright, now you're with me here, Mr. Joel, your tutor for Mathematics Form 4 here, and I just want to welcome you to ITTV. Alright boys and girls, today we are beginning with Chapter 1, Lesson 1. And this chapter is called Standard Form. But the first part of this chapter is called Significant Figures. Alright, to check out what it is, let's look here. Significant figures of a number are those digits that carry meaning, contributing to its precision. Alright, what is all this about? Alright, listen here. You have learned how to round off a number, right? Previously, alright, to a certain number of decimal places. 2 decimal places, 3 decimal places, 4 decimal places. Alright, what are all these? These are used to provide an accuracy, alright, for that number. Now, we are learning a new way to round off a number, and that is called significant figures. And again, it is the digits in a number that are important to determine the accuracy of that number as a whole. Alright, so significant means important, figures are digits. Every number contains digits that are important, and it will tell you how accurate that number is. Why do we need them? That brings us to our segment of mathematics in life. Alright, I just want you to take a look at the instruments here. Alright, there is an ammeter, there is a thermometer, and there is a weighing scale. And why are all these pictures shown? All this involves readings, taking of measurements, right? You use the ammeter to measure current flow in amperes. You use a thermometer to measure the surrounding temperature in Celsius. And the weighing scale, right, to determine the mass of products bought, right, from a market, for example. Alright, now, the problem is that all these instruments cannot be used to carry out a reading of 100% accuracy. No readings can be 100% accurate actually, you know. Actually, all measurements are just a form of approximation to be as close as it can get. What do I mean? Okay, I'm going to pick up an instrument here. For example, I just want you to take a look at this beaker. Alright, if you notice carefully, all the scales here, alright, are 0 ml, 100 ml, 200 ml, 300, and so on. When water is poured inside this beaker and the volume is taken, actually there is no way you're going to get the actual volume to 100% accuracy. All the volume will be taken to its nearest 10 volume. Alright, or take another instrument, for example, the thermometer. Alright, if you look carefully at the scales of each of the readings, alright, you can get, for example, body temperature 37 degrees. Alright, there is no other way you're going to get, alright, closer than that. So every figure has been rounded off to a certain number of digits so that it will provide you with a certain degree of accuracy, alright, for any instrument. Alright, now, what are the common abbreviations used to represent the word significant figures? Well, you can use sig.fig. Alright, it represents significant figures. Alright, to cut it short, sig.fig. Or you can also use s.f. Alright, s is for significant, f is for figures. Alright, you will use it later, alright, when you get a number to determine how many significant figures there are. Alright, let's move on. The concept of significant figure is often used in connection with rounding, and I've told you this just now. When it comes to significant figures, you are simply rounding off a number to a certain degree of accuracy that you want or that is required of any form of measurement. Significant figure rules. Alright class, I want you to pay attention closely because now significant figures is not as easy as decimal places. Alright, there are rules that you must follow, 5 in total. Alright, but now we're going to go through each rule one by one. Okay, in rule 1, all non-zero digits are always significant. Example, 4.321 has 4 significant figures. So this number has 4 significant figures. Alright, what does this rule actually? When you have any number, doesn't matter whether it's a whole number, whether it's a decimal. If all the digits are non-zeros from 1 to 9, all of them will be considered significant figures. Let's look at B, 519. Can you see the digits there? Are there any zeros or not? No, right? 519. There are 3 non-zero digits. So in rule 1, it says that every non-zero digit is significant. And since 519 contains 3 digits which are non-zero, all of them are significant. So, look, all 3 are significant figures, and this number is said to be 3 significant figures, or 3SF. So that is rule number 1. Remember, all non-zero digits are significant figures. Alright, let's move on to rule 2. All zeros between other non-zero digits are always significant. So when we want to determine significant figures, one digit that plays a very important role is actually 0, okay, because it determines the difference between all the rules. So look carefully at rule 2. All zeros between other non-zero digits are always significant. Alright, example A, 401008. This rule simply states that if a 0 is between 2 non-zero digits, or it is trapped, okay, between 2 non-zero digits, that 0 is considered significant. So in rule 1, all non-zero digits are significant, and in rule 2, if the 0 is between non-zero digits, that 0 is significant. Alright, so look at this number again. Since the zeros are between non-zero digits, none of the zeros are exposed, so this number has 6 significant figures. 1, 2, 3, 4, 5, 6. Left to right. So this number is considered to have 6 significant figures, or 6 SF. Alright, one more example for you. In B, the number 30000001. There are many zeros, right? But look again at this number. Are the 5 zeros there trapped, or are they between non-zero digits? Yes, they are between the 3 and the 1. So as long as the zeros are between any 2 non-zero digits, the zeros are significant. So all these 5 zeros are considered significant, added with the 3, which is already significant, and the 1, because they are non-zero digits. So all 7 digits are significant. And this number is said to have 7 significant figures. Alright, let's move on to rule number 3. In rule 3, leading zeros to the left of the first non-zero digits are insignificant. Alright, I want you to understand the sentence carefully. Alright, don't be confused. Alright, the leading zeros, this means zeros before a number in a decimal. Alright, now let's look at example A, 0.005389. Alright, look at the rule. We know that 5389, these are 4 significant digits already. But are the zeros before the 5 significant or not? Well, they are not. Alright, because rule 3 says that leading zeros, means zeros before a non-zero digit, they are not significant. So this number only has 4 significant figures starting from 5, 3, 8, 9. But this whole number is said to have an accuracy of 4 significant figures. Okay, one more example in B. 0.788. There is one leading zero in this number. Okay, and remember, leading zero is always when the number starts with a 0. Alright, before it reaches a first non-zero digit. So that 0 is not a significant figure because of rule 3. So 0.788 will only have 3 significant figures. Okay, starting from 7, 8 and 8, which are 3 non-zero digits. But the whole number will have only 3 significant figures. Alright, let's move on to rule 4. Trailing or ending zeros to the right of a decimal in a number are significant. Alright guys, as I told you earlier, the difference between the rules are just the zeros. Okay, so now instead of leading zeros, we have trailing zeros. If leading zeros are before a number, trailing zeros are after a number. But look carefully. In a decimal, if there are zeros after the point, okay, all those zeros are significant. Means they are considered part of the significant figures of that whole number, you know. So let's look at A, 43.00. Okay, how many significant figures are there? 4 and 3. From rule 1, they are always significant. But look at the 2 zeros. They are after the point. Okay, 0.00. So when you have this, it is called rule 4. They are called trailing zeros. So in this case, both of these zeros are significant figures. So follow me. This number has 4 significant figures, which is the degree of accuracy. Let's look at another example. 7.90. I'm sure you know what a trailing zero is. It is always the zero at the last. Alright, if the zero is always at the last and that number is a point and the zero is after the point, it is always called a trailing zero and it is significant. So 7.90, how many do you think? There are 3 significant figures. So apart from 7 and 9, that 0 also is, because it is a trailing zero. So this number has 3 significant figures, or 3 SF if you want to write it in abbreviations. Alright, the final rule of significant figures: trailing zeros of a non-decimal are not necessarily significant. Alright, rule 5 is what I call an ambiguous rule. Why? Because this rule is actually uncertain. Alright, because trailing zeros of a non-decimal, if we have a number which is not a decimal and the zeros happen to be parked at the end of that number, that zero can or may not be considered as a significant figure. Alright, I want you to see here to understand what I mean. In A, in the number 1900, there are 4 digits, right? All 4 of them can be significant figures. But at the same time, the 2 zeros might not also be considered significant figures. So this number can be 4 significant figures, or 3 significant figures, or 2 significant figures, because the zeros are not certain. They might be or might not be. Alright, in example B, 594000, the 3 zeros are trailing zeros in a non-decimal. So they might or might not be considered as significant figures. So in B, this number can have 6 significant figures, 5 significant figures, 4 significant figures, or 3 significant figures. Alright, we'll do more in the example that's coming right after this. Alright, now let's move on to our exercise. How many significant figures? There are 5 numbers here, okay? A, 12.543, B, 2.302, C, 43.310, D 0.002320001, and E 47800. Alright, now I'm going to show you on the board, alright, about the significant figures and how many are there in each number. $12.543. How many significant figures are there? Rule 1. Because there are no zeros, automatically every digit is a significant figure. So you have 1, 2, 3, 4, 5. So all of them are significant, and this number is said to be rounded off to 5 significant figures. Alright, in B, 2.302. Can you identify which rule is playing in role here? The first two rules. Look carefully. The first rule says that 2, 3 and 2, since they are non-zero, they are significant. But what about the 0 here? The 0 is between two non-zero digits. So according to rule 2, such zeros are significant. So this makes all the digits in this number significant. And how many are there? 1, 2, 3, 4. Remember, we always label from the left to the right. So this number has 4 significant figures. Alright, let's take a look at C. 43.310. What rules are here? I bet you know. Rule 1 for the non-zero digits, and there is rule 3. Alright, rule 3 states that trailing zeros in a decimal, as long as there are any zeros after a point, the zeros are significant. So this 0 is also significant. Okay, so there are 1, 2, 3, 4, 5 significant figures. Alright, what about the number in D? Long number there. 0.002320001. Alright, there are many rules here. Look carefully. These are called trailing zeros. Alright, because they are on the front. Okay, so when you have these kind of zeros before any non-zero digit, they are not significant. Okay, because they are before. So these 3 are not significant figures. They are called leading zeros. What about the zeros here? Yes or no? They are significant because remember, the rule states that as long as they are trapped between two non-zero digits, they are significant. So together with 2, 3, 2, they are significant. 1, 2, 3, 4, 5, 6, 7. This number has 7 significant figures. So you must really understand the rules to differentiate between leading zeros and trailing zeros, alright, in a decimal. Alright, and in E, the number 47,800. Alright guys, this is rule 5. Rule 5 is a bit uncertain because the zeros here, yes, they are at the back and they are called trailing zeros, correct? But now, it is not a decimal. So these two zeros cannot be considered as significant figures. And how do you know that? It depends on the situation. Okay, so there are already 3 significant figures here, 4, 7 and 8. Okay, so the degree of accuracy can be 3 significant figures. Okay, that is assuming both of them are not. And if this 0 also can be considered significant figure, that makes the significant figures of this number to be 4. Okay, and that is assuming the last 0 is not significant. And lastly, this 0 also can be considered, and that makes it 5 significant figures. So in short, in rule 5, the zeros may or may not be considered as a significant figure depending on the situation. Alright guys, now it's your turn to determine how many significant figures, alright, and it's our quick test segment, alright. You do them by yourself and we will discuss the answers shortly. State the number of significant figures in each of the following numbers. In A, 0.01 00030. In B, 43.128. In C, 29.00. D, 3406, and E, 380. Alright, I'll just give you some time. We'll be back shortly. Alright students, I'm sure you have your answers with you. How many significant figures are there in these 5 numbers? Alright, let's start with A. It has 6 significant figures. Alright, remember the leading zeros in the front are not, the in-between zeros are, and the trailing zero is. Okay, 6 significant figures. What about B? 5 significant figures. This is rule 1. As long as there are no zeros, all the non-zero digits must be significant. In C, 4 significant figures. The 2 zeros at the back are called trailing zeros, and since they are after a decimal, they are always significant. So apart from the 2, 9, both of them are 2 plus 2, 4 significant figures. In D, 4 significant figures also, because there are 3 non-zero digits and 1 zero that happens to be between 2 non-zero digits. Okay, what about E, guys? This has a 0 at the back, a trailing 0 in a non-decimal, means a number that is not a point number. So that 0 may or may not be. So we have 2 answers actually for this question. It might be 3 significant figures, which is 3, 8 and 0, or 2 significant figures, which is just the 3 and the 8 and the 0 is not. So there are 2 situations here. Alright guys, we have come to a conclusion of lesson 1 of chapter 1. Alright, let's quickly recap what we have learned today. We have learned about significant figures. Alright, and one mention of the word significant figures will tell you that it is associated with rounding. How you round off numbers. So it is actually an alternative, alright, compared to decimal places. But when you round off a number, according to the number of significant figures, you must remember the 5 rules. Alright, so I advise you to learn, especially rules 2, 3 and 4, where there are a lot of mentions of zeros. Alright, so understand the rules carefully and you will be able to determine how many significant figures are there in any number. Alright guys, thank you for watching lesson 1. Alright, I hope you enjoyed yourself today. Alright, and we'll be back in lesson 2. Alright, it's goodbye and take care. See you.